Okay, class. We want to go by the example we do in class today, yesterday. So to explain how does it work using elementary row operation on a matrix. Actually, we try to mirror to that of a system of linear equations. All right. I think we rushed a little fast yesterday, so let's slow down a little bit. All right. So what we want to do, the elementary row operation is simply a way of elimination method to solve a system of linear equation. So we want to use elimination method. So we want to eliminate this is 4x1. Okay. So what we want to do is equation 1 times 4 added to equation 3. Okay. Equation 3. So simply this become 4x1 minus ax2 plus 4x3 equals to 0. So if you look at the right hand side, simply representation is this becomes 4 negative a 4 0. So when added to row 3, so what do we obtain? So what we have is this, right? Okay, what you have is this. So you cancel out 4x1 and x1 cancel out. Minus x2, 8x2 plus 5x2, you get what? Negative 3x. 4x3 plus 9x3, you get what? 13x3. Same thing, similarly for the number. All right, eventually we're going to drop all the variables, just operate on the matrix a little bit easier. Look at here. 4 plus negative 4, you get 0. Negative a plus 5, you get negative 3 right here. 4 plus 9, you get 19. 0 plus negative 9, you get negative 5 back. So what's the next thing to do? Remember, we want the diagonal matrix to be 1 here, 1, 1, and 1. That's what we want to do. Okay? So we want this number to be 1. So what we do is multiply the entire second row by the half. We understand that's equivalent equations. So what we did here is multiply the entire second row by 1/2. Okay? So what we have here is that become, okay, that become 1, negative a become negative 4, a become 4. Similarly, 2 become 1. You see, it's a little easier just dealing with what matrix negative a become negative 4 and a become 4. So what's next to do? Next we want to get rid of this guy. We want to get, you consider it convenient. If between 2 and 3 to work out the negative 3 is a little harder, but if now this is 1, it's easier to deal with this negative 3 here. We simply equation 2 times 3 added to the equation 3. Equation 2, all right, so that become 3x squared, right? Negative 12x cubed, x3 and 12. Well, similarly, the number becomes times 3, negative 12, and 12. Then we add it to the next one. Okay? As you can see, you cancel out 3x squared, negative 3x squared, 0. Negative 12 plus 13, x3, 12 minus 9, you get 3. But same thing, similar, a little bit easier, just dealing with numbers. So 3 minus 3 gets 0. 12 minus 13, you get 1. And 12 plus minus 9, you get 3. Well, finally, you want to go back. Now you go down to this row. You make the 0, 0, 0 here, right here. Now you go backwards. To that one, you want to take out this one, make a 0. So what do we do here? We can say, all right, the third equations times what? Times 4 added to the second equation. So that becomes a little easier now. So 4 and 12, right? Become this. So what happened? Okay. Well, we'll kind of skip that, right? Let me just fill in the blank. So that will become, 1, negative 1, negative 2 is 1, 0, 0, 1. So 0, 12, that's 16, right? That's 0, 0, 4, 12. And also want to deal with this negative 1 here. So what do? We simply Okay, want to get rid of this 1 right here. So what we can do is just equation 3 times what? Negative 1 added up. So what we get? We will get, okay, so times, sorry, that's 1. My bad. 1 and 3. Okay, so times negative 1 added to it. So all we have here is 1, negative 2. So take negative 1, 0. That's what? Negative 3. 0, 1, 0, 16, 0, 0, 1, 3. Now one more to deal with. We want a diagonal one only. All the rest of values, so 0. So we want this negative 2 to go away. So we can say, well, equation 2 times 2 added to equation 1. So what we get. Okay, equation 2 times 2, let's see, that's a 0, 1, 0, 16, 0, 0, 1, 3. All right, so since it's all the 0 have no effect, this 1, right? So times 2, the points to take the 0. 0 have no effect. The last effect is 36, 32, 2 times 16, 32 minus 3, you get 29. So now we have this. So if you put it, put on the variable, corresponding equation would be x1 equals to 29, x2 equal to 16, and x3 equals to what? 3. Of course, all the 0 just simply, we don't have to bother to write it down. So the solution is 29, 16, and 3. Okay, so let's go back here, right? Let's go review. Elementary row operation simply is you can, the 3 principle, right? We didn't exchange any 2 rows at this point, but we simply multiply any rows by a number added to another row. Okay, and you can multiply any row by a constant, you will not change the solutions. All right, so the point is, get to this part. We get the final answer is upper triangle all 0, lower triangle all 0. And the way we did it is we first use the first one row, eliminate everything below. And then second row, the first value, eliminate anything below. Then we get 0, 0 here. And then we go backwards. With this one, you get rid of this 2, you get 0, 0. Then this guy, get rid of that one, you get 0 here. Then we get obtain the solutions. Of course, it's tedious to do it by hands. But if computer can get this algorithm, you can just write an algorithm and tell computer to do so.